Okay, good morning, good afternoon, or just plain hello. I hope you are all doing really well today. It is currently, or today at least, it's the 27th of July, and this is grade 7 coding. We are looking at 4 loops with artist, puzzle 9 to 12, and then we are going to start with some revision, because for this week, there will be informal assessments that will be available to you from our Africa Teen Geeks website, and you will see that on Wednesday. The coding one will be available. For some reason, the entire last week, I thought that the 29th is on Friday. So I kept telling everyone we'll have our informal assessments on Friday, but that's not the case. It's on Wednesday. So just to clear that up, the 29th of July is Wednesday, and we will do some informal assessment there. So what I'm going to do is just finish off the lessons that we're in on the code.org platform, and then we'll jump into some revision. And I've thought it good to take this entire week and just review some of the work and some of the concepts that we've done in the past. Especially, I went through everything over the weekend as I was preparing my lessons for the week and putting my lesson plan together, and I took out the most important concepts and ideas, when it comes to coding JavaScript on the Blockly platform. So that is what I've done, and that is what our week is going to look like. So for those of you that don't know me, I am Mr. Paul de Klerk, and I am the senior phase coding teacher for STEM Digital. And we are powered by Africa Teen Geeks, right? So all of our social media, our websites, and our YouTube is under the Africa Teen Geeks name. So don't get confused with that. If you are joining us on YouTube, go ahead to the video description box below. You will find links where you can register to come and join us in our live lessons. So if you are a student that has access to an email address, you can register for yourself. If not, just get a parent or a guardian to register on your behalf. There will be a confirmation email sent out to the email address that you register with. So you must have access to that email address. We're doing this to try and help keep you guys safe in this online space, right? Once you make it difficult for bad doers, they tend to not want to participate. So we just have that extra step so that we don't have our links to the Zoom meetings publicly available all over the internet, but specifically targeted to people that are interested to be here. Okay. That being said, if you do join us in class, please remember the chat box is there for me to share resources with you. So I am the only one that is allowed to post a link in there, and that's only the link to the coding platform. I will not post any other links there. If you see a link to a Zoom meeting, or you get private messaged by someone with a link to a Zoom meeting or asking for your email address or your contact number, that wasn't from me. So please, please, please don't answer that and just inform me in the chat, okay? Right, and the last one is, I don't have issues with this age group, but I mention it always. Please try to keep your video cameras off. Obviously, accidents happen. If you switch it on, we'll just switch it off on your behalf. But if the same thing happens 5 times in a row, it doesn't look like an accident anymore. All right, so I think that's it. We are good to go. Let us jump into this. So here is a quote. It says, "From phones to cars to medicine, technology touches every part of our lives. If you can create technology, you can change the world." And this was said by Susan. Now this surname I cannot pronounce. Wojcicki, perhaps? I don't know. But anyway, she is the CEO of YouTube. And I always take it interesting, or find it interesting, to look at these people's ideas and the way that they look at things, right? So we've had quotes from Mark Zuckerberg, from Bill Gates on here, from the Apple founder, Steve Jobs on here. So all of these people, they have this outlook in life. And what that outlook basically says is that technology, and more importantly, computer sciences, are becoming a major part of our daily lives, right? So you can see here, from cell phones to cars to medicine. So even the stuff that keeps us healthy, the things that are being developed to fight this pandemic that the world is currently facing, It's been done by technology. And the programs and the software that makes that technology work is created by people like us who know how to program computers, right? So I've said this before. A Microsoft study has shown that at least 60% of STEM vocations will be computer science based. They will be completely reliant on computer systems to happen. Okay, and already that is the case in most of these areas and these types of jobs. So what that means to say is, if you can create technology, if you can create computer code, if you can create programs, you can change the world. And I truly believe that. Right, so let's carry on. Some terms that we need to know. First one, variable. Variable is set to a certain value that stays constant or that changes as the code is executed. Okay, so we've looked at this in both ways. We've looked at variables as a constant, and we've looked at variables that change. And currently, we're looking at the one that changes, right? Because we are doing for loops. And these for loops, they basically set a variable, and that variable then changes each time the loop is run. But we'll look at that in a second. Okay. So here we see for loops are loops that have a predetermined beginning, end, and increment, step interval. So there, that increment or that step interval, that's where the variable changes. Okay. But we set where the variable starts and we set where it ends. So we basically control the variable from the start to the finish the entire time through. Okay, so today's lesson, as I said, we're looking at for loops with artist, okay, of which puzzle 12 is going to be homework. And then we're going to jump back into review, snowflakes with Anna and Elsa, okay, which is basically only Elsa, but they have it there as Anna as well in the name, so that's what we'll call it. Okay, just check. Awesome. I'm going to share my coding screen in a second. And I want to go back to lesson 8 because we need to review just to make sure that I give you enough time to, I'm just going to remove all of this to get to the link. There we go. Struggling for my words so early on a Monday morning. And it's not even early yet. It's already almost afternoon. Okay, there we go. Good. So all you need to do is once you've accessed the link and you have your coding platform open, just quickly type a yes in the chat box. So as you know, on a Monday, just in case we have new viewers on the YouTube channel or perhaps new friends in the classroom, I just want to run through everything with you before we get going, okay? I don't want anyone to fall behind. Although we are in very far advanced in the lessons, you can still catch up if you're new, okay? And I'm going to show you how right now. So what you see in front of you is what we call in computer language a GUI, or a graphical user interface. And what that basically says is the way that we interact with the computer happens through this interface that we can see in front of us, okay? So for the most part, when computers talk to one another, when they communicate with each other, or when they communicate with their internal systems and devices such as the hard drive and the RAM and the processor and the graphics processor and so on, they use what is known as binary code, a bunch of ones and zeros. Now, our human brains, they just are not equipped to communicate in that way effectively. So what happened is, this graphical user interface was designed. So what this gives us is it changes that binary code from ones and zeros into letters that we find in the alphabet. It changes into colors that we like to see. It changes into graphics in the form of images that helps us to understand how to interact with this platform. Okay, so here you can see all of this is a part of the graphical user interface. Everything that you see, which looks nice and doesn't look like a line of ones and zeros, right? That is the GUI. So to understand this GUI and how to use it, we need to know the following things. This is lesson 23, 4 loops with R-Test. If you click on this, you're going to go back to that page where we just were. And that page is a section that I specifically created for the grade 7 class. So you can actually keep the link open, this link here in your browser. You can keep your browser open after we finish our Zoom lesson. And you can go and click there and go back to lesson number 1 if you'd want to do that, okay? So that you can catch up. You can also copy the link from your browser here and save it on a text editor, wherever you do your text editing, Notepad or Word or Google Docs, whatever, right? You can save it there so you can go back and just do this whenever you want to. Important though, if you do like coding a lot, and this is something that I had to learn very quickly, once you start to spend many hours behind the computer, you must remember to sit up straight for your back, and every, I'd say 40 to 45 minutes, that's what I do personally. This hasn't been medically proven, but just for myself, I pause whatever I'm doing, I stand up, I walk away from the computer, I try to get outside or at least look at a window to look as far as I possibly can. I find the furthest thing away from me and I try to focus on that, okay? This helps to relieve the pressure on your eyes as well as makes your headaches go away if you do tend to get headaches due to using technology for such a long period of time. Right, so within this lesson, these are the puzzles that are available. The green ones we've done, the white ones we're still getting to, the flags are lesson extras, okay? Here are the instructions. So for the most part, this will tell us how and what we have to do to solve this puzzle. But it doesn't always in detail explain why. So that is why I am here to help you out with that. On this side is our play area. So this is where we see the magic happens. And you can make this smaller or larger. I like it nice and big so that I can see what's happening. So whatever we code will be visible here. This is our toolbox and it has many different blocks. So these are action blocks. These are loops. These are brushes that sets the pattern that he draws with. And these are comment blocks, okay? So you can choose one of them and drag them onto your workspace. So this is the next area of our GUI is our workspace. And this is where we actually code, okay? You have to make sure it connects. If it doesn't connect, it looks like this, it will not run. It has to be dark like that. Now this block isn't the actual code. You can view the actual code here. And this is what we know as text and line-based coding, but we are learning it in a Blockly system, block-based coding. And you can see there are even universities such as Berkeley and Harvard that teach and learn JavaScript on the block-based system, okay? So now you know how everything works. Oh, last thing, if you don't want this, you can just drag it away and drop it there. So in the chat box, if you are ready, type a yes, and then we can start coding together. All right, Angelina and Bright is ready for us to get going. Awesome. Okay, so we've done this already, but let us quickly see what to do. So what we had here, remember now, when we see this symbol, it means that our code gets carried over from one to the next. So I'm going to do both coding out of my head from what I remember and what I see is needed here. I think let's start this code from scratch so that we completely understand the sequence because we're going to keep using it when we continue. So the first thing we need to do is you need to move, obviously, right, by a certain amount. So we need to determine what that amount is. Sorry, I just want to quickly, my system is going crazy here. Okay, there we go, that's better. So let us just use this to figure out, because this is where we will start our for loop. So we first need to measure, okay? Now it's easier to just use this and guess until we have it right than it is to try and use a ruler to measure there. So I'm gonna start with 20 and let's see. Let's run that. Okay, we can see that line is too long. So 20 is not the right one. What does 15 look like? And 15 looks good. But the first thing I see also is it's so thick. I can barely really see what's happening there. So what I want to do is take the brush, set it to a 1. And now look at how thin that is going to become. There we go. That's much better. Perfect. Okay. So we start at 15. Now we need to, as we work with our for loop, then we will try to figure out how long the sides are. If I have to guess, remember this play area of ours is 400 by 400. So if I have to guess, I'm saying these long ones would be around about 300. I'm not sure. Okay. So now what we're going to do is take our for loop and place it in here, right? You get that under loops, for loop. Now we want to set this to 15. We know it's 15 because we've tested that, okay? So that works, but this we're not going to move forward by 15. We are going to move forward by counter. Now remember how this works. For loop also sets a variable named counter, and it assigns the value of 15 to that variable, right? So the first time this is going to run, it's going to be 15 pixels long. Okay, now this doesn't assign 15 pixels. This assigns a value of 15. We make it 15 pixels when we place it in here. But if we place that in a turn, let's say turn, for example, turn right. If we have counter in here, I'm just doing this as an example, this will become 15 degrees, right? So it's important to remember that this variable can be used for there and there. What the variable represents is going to depend on the line of code that it's in or the block that it's in. Okay, perfect. We're good to go. Now I can obviously see this is a square, right? So I'm just going to place this in a 90 degree there because we know that that's 90 degrees. Now I'm going to test it just the way it is. I'm going to run it and I can see that doesn't work properly. First up, we are jumping with too much from that line to that line. So let us change how much we do that by. So let's understand this. What we said now is we start with a variable at 15, counter is 15. Then we want it to repeat until this variable's value is 100 or higher. You can see that in the line and text-based coding there. Until it is larger than or equals to 100. Okay, but each time the loop runs, we don't want to count 15, 16, 17, 18, 19. We want to add 10 to that. So we are doing 15, 25, 35, 45, and that's going to keep going until this is hit. But we can see that from that 15 to there, it becomes too much, right? It changes too much. So let's just add 5 and have a look. That looks almost better, almost better. Okay, so something else that we first have to figure out as well is up to where it's supposed to go, right? Let's run this. Okay, so 100 ends here. So obviously 100 is not enough, okay? Our increment is still a bit big. We can change that a bit later, but now let's just get it to the end. It's going to make it easier. So I'm going to try this with 250 and see where we finish. Okay, this line still seems to be too short. Okay, so we're going to take this up to 300. Now, if you've got this, that's awesome. But remember, I need to cater for people who haven't done this before. Okay, so that gives us an idea. This looks almost correct lengthwise, right? But this still doesn't look right. So let's increment with 1 and see what that looks like. Okay, that doesn't look right either. Let us increment with 2 and see what that looks like. Ah, that almost seems like it's going to work. Maybe not. Now let's just play with the angle until we've got this. What would it look like with 89? And look at that. So I'm going to go back to this, right? Remember now, we followed the problem-solving workflow. We always speak about this. What does the problem-solving workflow dictate? It says we need to identify the problem. It says we need to create a solution for the problem. Then we need to test that solution and we need to adjust the solution. And then we test and then we adjust and test and adjust and test and adjust until we don't need to adjust anymore. That's exactly what we did now. We started this from having nothing to actually having the entire picture finished. We first determined this length so that we had a starting point. That was our first problem. We don't even know where to start. So we first tested just using a move forward to determine this value. That was our first problem. The second problem was, okay, now that we have this value, we need to figure out how much to step and where to finish. Almost these two sort of work hand in hand, okay? But for that to be able, for us to be able to calculate that, we have to sort of replicate the shape a little bit. So we just added this move forward with the counter variable in there because we are adjusting that variable here, right? This is what's going to determine the length at the end of the day. And then we placed the turn in there, but we had it to the standard 90 degrees so that we can first determine this length and this step before we start playing here. So then we did that. We ran it, changed this to 250, saw that didn't work. Changed this to 5, didn't work. Changed this to 1, it didn't work. When we had it on 2, it almost looked good. So then we just left it there and we played with this until we got it. Okay. And you can see there, you can run this multiple times. You're not going to get in trouble. It's not going to break. It is the way that we learn and how we figure things out. Are you happy? Can I continue? I see there is one already. You need to remember, if you upload screenshots to the chat, I can't open it when I'm sharing my screen. So I'm trying to download it and I'm hoping it won't create problem for me. It doesn't seem to. Okay, so it's downloaded without issues, but I won't be able to view it. I'm going to continue. I'm assuming that you are ready. Okay. So let's increase this. And then let's have a look at this. This says, take the angle down to 72 degrees to get a spiral pentagon. Okay. So this was the code we just created, but because of the symbol, you can see it means that it will continue with us until we don't need to use it any longer, right? So we have this already here. All we need to do is what they tell us. Take that down to 72 and run it. And then we see, oh, they were not lying. 72 seems to do the trick, okay? Let me just show that to you one more time. The only change we made was to change that to 72. And now it created more lines, 1, 2, 3, 4, 5, before it almost closed, okay? Full rotation, right? So let us continue then on to the next one. I hope you're ready, and I'll share the link again when we get to the next one. Nope, that's not what I wanted to do. Yes. Okay, so now we're going to do something. If you have a look at this little shaded, these shaded lines, right, in our play space or play area, you see that it starts out very light and it gets darker and darker and darker as we progress. So what this is saying is, use the counter inside the set alpha block to get something like this faded center. This hexagon pattern was made using a 60-degree turn. Okay. So two things that we have to change. First one, the 60 degrees is very easy. We just do that, that's fine. Now we want to do the set alpha block. So we need to find that. There isn't a set alpha here. There isn't one here, but it is here. So you could have found this very easily just by knowing that this is where we're going to change the brush styles, okay? So I'm placing it before the loop. I want to show you something. And we're going to add the counter. Look what happens. It stays dark. from the beginning, right? Let me remove this and just run it without that so that you can see. It's the same thing, okay? If we place this here, the same is going to happen. Okay, so you need to remember code runs sequentially. So what we tell it to do first, it's going to do first. So here we have this placed in, but the variable for counter hasn't been created yet by this time. It's only created in this for loop here. So there's nothing for it to refer to. If we place it there, it's going to finish this for loops, all these repeats. Then it's going to set the alpha to counter once this is done. So at the time that this is finished, counter's value will be 300. So they're going to set alpha to 300 and that's it. But he's not drawing any lines after that, so you won't see it. For this to work, you have to place alpha inside the for loop. So just so you know, alpha in web design or web development, we call this opacity. And it's just how light or dark the line is. Okay, so there you can see that's how it works. Now you can see it goes from lighter all the way, getting darker and darker and darker because the value of alpha increases each time. Right, does that make sense to you? Are you happy? Can we continue? Do you understand why that set alpha needs to be inside the loop? If you are happy, type a yes, and then we will continue. Anyone there? Okay. Can't wait too long because there are YouTube viewers as well, so I'm just going to continue. Right. This is one of those puzzles that teaches us how to debug. Debug means to fix mistakes in code. And because of the way that this is set up, it's going to teach us how to read the code. Okay, so let's see. We use the counter from our for loop to change the width of the brush on this drawing. What will happen when you click run? The artist will draw a straight line that increases in thickness from one side of the play space to the other. Okay, we don't know yet. We'll check now. The artist will draw a spiral, and each time through the for loop, the line gets longer and thinner. Okay, we'll figure that out shortly. The artist will draw a spiral, and each time through the for loop, the line gets longer and thicker. Okay, and D says, I don't know. So I don't like us choosing D, so I'm just going to close that. And what we have to choose is one of these options. Okay, we're coders, we have to try and figure it out. And if we do get it wrong, then we learn, so that's fine. Okay, the artist will draw a straight line that increases in thickness from one side of the play space to the other. Because there's a turn in here, I highly doubt that he's just going to draw a straight line. Okay, so A already is not an option for us. Now we need to go through the others. The artist will draw a spiral, and each time through the for loop, the line gets longer and thinner. Okay, so here we have this move forward by counter, right? And what is going to happen with this is it's going to start from 1. Counter will start from 1. It's going to go to 200, and it will increase by 5 each time, right? Increase by 5 each time. So that is going to make the line longer and longer and longer. So it's going to be 5 pixels or 1 pixel, depending. We'll have a look at exactly how this one acts. But let's say 5, then 10, then 15, then 20, then 25. So it's obviously going to go longer, right? So we can see that the line will get longer. So both of these are still good. We now need to figure out if the line will get thinner or thicker. Now this is where it catches you out quite quickly, quite easily. It says here to set the width is counter divided by 5. So because it's divided by, you feel like it's going to make it smaller, which it does, but that increases each time. So let's look at the math behind it. If you have 5, the first time this runs, divide by 5, it's equal 1, right? So the width is going to be set to 1. The second time this runs, the counter is now 10 because it is increasing by 5. And 10 divided by 5 is 2. The third time it runs, counter is 15. 15 divided by 5 is 3. So you can see with the width, even if it's divided by 5, it's going to make the number 15 smaller. But number 15 becomes number 3 after it's been divided by 5. It is still bigger than the one before it, than the previous time the loop ran. So what's happening is this is getting bigger and the result of this equation is getting bigger. So our line will get longer and thicker. Oh, now I clicked on the wrong one. There we go. Longer and thicker. And if we run it, you'll see. Look at that. How it changes, right? Okay. So this is going to be your homework, right? But I'm going to leave this with you. I'll come back to this. For now, I'm jumping to the other lesson that we're going to do for today. And then right before I say goodbye, I'll share this link with you. All right. Snowflakes with Anna and Elsa, puzzle 4, 5, and 6. Okay, once you're in, just type a yes for me in the chat box, please, so that I can be sure. Okay. So let's make a snowflake and let's make it special. Okay, so now let's just remember. For this, we've probably already created code. Let me just refresh this. That code I removed now, I forgot it's supposed to be there. Okay, we'll just start from the beginning, that's fine. It's going to take some trial and error because I'm not sure about the measurements. Let's just jump back to 3. Okay, this is giving this to us. I'm going to run this. Okay, let's try it on 4 now. Okay, we'll just start from the beginning, that's fine. Okay, where do you need to add code if you want to draw a tiny square at the tip of each long line? Just see here. You can try whatever you want in this puzzle, but here is an idea. Try making, that's better. Try making a tiny square at the end of each line. Each side should be 15 pixels long. You should turn by 90 degrees, repeat those actions a total of 4 times. So before we can do that, we need to do what we have in here. And we want to use the comments. So let me just quickly run through this one more time. The comments are blocks that we add to help us navigate through our code, right? For us to read it. And let's say you're working on a project, a team project, and somebody else needs to code on your program. You want them to have the ability to read the code and understand exactly what is going to happen or what each sequence is responsible for, instead of having to try and guess each time, okay? So what my advice is to use comments. Now, comments do not add to your work block count on your workspace, and it also does not run. It's only there for you to read. Okay, so I'm going to name the first one hexagon, because we know that this is made up out of a shape of hexagons. And I'm going to have to experiment now because I deleted the code, so I'm not sure how long that should be. 50 looks fine. Then I want to turn right by 60 and test it. That looks good. Then I want to repeat that obviously 6 times. Let's test that. Okay, that works perfectly. Now we're going to do the code for the long line. So I'm just typing that in there to make it easier for myself. There's a long line that I have to draw there, right in the center. So I'm going to have to turn. Let's see if we turn by 60, if that works, and it does. And then I think that long line is 150 pixels. Just see. And it is. Lovely. Okay, so now before we do all of this, we need to figure out how to make it do that many times over. So we're going to place everything in a repeat, and we're going to do it 6 times and test. And now we see that's not what we need. Look at what happens there, right? So we obviously need to add something, which is this jump to the middle or the center. And this we can just call the positioning. What that means is it is purely there to line her up for the next line. Okay. It doesn't actually help any of the other things happening, but it does place her in the right position to start again. So now we have to do the code for the small squares. Now we need to remember, we don't want to do the small square after the positioning. If we do it after the positioning, we're going to jump to the center and middle and then draw the small square. We want to draw it when we are there. So that happens over here. And we can call this the small, actually I just want to call it square because I know what's coming, square, right? So they tell us how to do the square, 15 pixels long. So let's add that in there. 15 pixels, no, that's 10, 15, awesome. It's going to be a 90-degree turn to the left. 90 degrees to the left. And we're obviously going to repeat that 4 times. Just put this in here and this there, and this goes underneath. Now if we run it, we're good to go. Okay, so a few things that I want you to pay attention to here. I know we did this quickly, but it's because it's a review puzzle. Pay attention to the sequence that this is happening in. First, the hexagon and what that sequence looks like. Then the long line and what that sequence looks like. Then the square and what that looks like, and then the positioning and what that looks like. Okay? Now think about how we're drawing it and relate it to the picture. First the hexagon, then the line, then the square, then we jump back to the center. Okay, so I hope that makes sense to you. I'm going to continue on to the next one. Try changing the shapes or the lengths of the lines to make this your own. Now, if we look at this on the left, now we should be extremely happy that we were using comments in our code. Because with comments now, it becomes very easy. The square is first, the hexagon is last. So all we need to do is take out the square, put this one back, take out the hexagon, put this one back. Put the square where the hexagon used to be, put the hexagon where the square used to be. Run it to see. Okay. So it's not right yet, but it's much better. That looks cool, actually. Now we obviously need to adjust. So we can see here, the hexagon used to have 50 sides. So now we're just giving the square 50 pixel sides. And where the square used to have 50, now we're giving the hexagon 50. What's important to note is I don't go and play with this code here or that code there, or look for code somewhere else. Because it's labeled, I can specifically fix the code that I'm working on. Okay, so this obviously isn't working correctly because we used to turn right with the hexagon and we used to turn left with the square. They've changed positions, so now it's the other way around, and look at that. So because we have labeled this correctly, 3 adjustments. Swap the square and the hexagon. Adjustment number 2, change the size of the lines. Adjustment number 3, change the direction of the turn. And we're done. Look at that. We're done, even so much so that we can finish this last one as well, and I'll have time to share the homework with you. So let me get to this. Let's try this. This time skate in a zigzag, and now they give us the zigzags, 45 degree turns, 25 pixels. Okay. So the only thing we want to do is to change this long line code. So we're going to take that out, place this back, no, with the comment. And we're just going to adjust the long line. So before we even try, let's just change the long line right where we are. So we're obviously going to move forward by 25. That's what they say there. And we're going to turn by 45. We don't know if it's left or right yet. We're going to move forward by 25 again. And we're going to turn again by 45. We don't know if this one is left or right yet, but we do know if that one is right, this one has to be left because we are making a zigzag. And we're going to repeat this 3 times because we're drawing 2 lines at a time and we have to draw 6 lines. They told us that. And look at that, we've actually done it correctly. There we're making that line. So now all we need to do is take this long line away there, place our sequence back up there, and drop this one back to where the line used to be. The long line has now changed into a zigzag line. And when we test this in sequence, we see that we're almost good, but there's one problem: the direction we're facing. So we want to place another turn after our jump to middle or center. And that works. I was just lucky that it was a turn right by 60 degrees, but we could have tested it if it didn't work and adjusted it. Okay, beautiful. I want to jump back to where we were and share the homework with you so that I can go back to my coding screen. Where are we? That was here. Okay, so this is a free play, right? What I want you to do is to create something amazing. And then the same way you did the screenshot to me now in the chat box for the one that did, you can send it to my email and I'll have a look at it and I will give you feedback. So we're doing 4 loops with Artist Puzzle 12. This is your homework. Creativity is the idea, right? So we're going to use code to get creative, and these puzzles are the best ones to figure out if you really understand all the concepts, okay? The next lesson, we're going to continue with revision, and it'll be loops with Ray and BB8, puzzle 7 to 14, right? Loops with Ray and BB8, puzzle 7 to 14. If you have any questions, that's my email address, paul@africateengeeks.co.za. You can also share your homework with me there. I'd love to see that, right? The next one is, you can search for Africa Teen Geeks on Facebook, Instagram, and Twitter, and you will find us there. We're on YouTube as well. So if you did miss a lesson and you'd like to catch up, you can head over there and search for this, and our videos are on there. Right, guys, thank you so much for being here. Have a lovely day. Please invite your friends to come and join us next time, and then I'll see you tomorrow. Bye-bye.